Hello. This time we will be talking a little bit about the most troubling subject, I must say, something we have mentioned previously, area where many of the greatest minds have difficulties in both thinking and defining, roughly speaking, a place where reality matches. This place, as you may have already figured out, is called quantum mechanics. Let's begin. Quantum mechanics is the part of physics that tells us how the things that make up atoms work. It also tells us how electromagnetic waves like light work. It is a mathematical framework, rules written in math, for much of modern physics and chemistry. Quantum mechanics helps us make sense of the smallest things in nature like protons, neutrons and electrons. Complex mathematics is used to study subatomic particles and electromagnetic waves, because they act in very strange ways. Quantum is a Latin word that means how much. So a quantum of energy is a specific amount of energy. Light sources such as candles or lasers shoot out or emit light in bits called photons. Photons are light packets. Each one has a certain little bit of energy. Isaac Newton thought that light was made of very small things, that we would now call particles. He referred to them as corpuscles. Christian Huygens thought that light was made of waves. Scientists thought that a thing cannot be a particle and a wave at the same time. Scientists did experiments to find out whether light was made of particles or waves. They found out that both ideas were right. Light was somehow both waves and particles. The double-slit experiment performed by Thomas Young showed that light must act like a wave. The photoelectric effect discovered by Albert Einstein proved that light had to act like particles that carried specific amounts of energy, and that the energies were linked to their frequencies. This experimental result is called the wave-particle duality in quantum mechanics, as we have mentioned in our previous parts. Later, physicists found out that everything behaves both like a wave and like a particle, not just light. However, this effect is much smaller in large objects. In the early days of quantum mechanics, Albert Einstein suggested that if it were right, then quantum mechanics would mean that there would be spooky action at a distance. It turned out that quantum mechanics was right, and that what Einstein had used as a reason to reject quantum mechanics actually happened. This kind of spooky connection between certain quantum events is now called quantum entanglement. Quantum entanglement is the name given to a special connection between pairs or groups of quantum systems, or any objects described by quantum mechanics. Quantum entanglement is one of the biggest parts of quantum mechanics that makes it hard to understand in terms of the everyday world. When we look at particles, we usually say that each particle has its own quantum state. Sometimes, two particles can act on one another and become an entangled system. When a pair or group of particles can only be described with one big quantum state for the lot, and not as a bunch of little quantum states put together, we say the particles are entangled. Well, it seems that we have crossed our time span. Before we finish, here are some of the people who discovered the basic parts of quantum mechanics. Max Planck, Albert Einstein, Satyendra Nath Bose, Niels Bohr, Louis de Broglie, Max Born, Paul Dirac, Werner Hessenberg, Wolfgang Pauli, Erwin Schrödinger, John von Neumann, and Richard Feynman. They did their work in the first half of the 20th century. Without further ado, I would like to thank you for listening and hope to see you in the next part.